Welcome to part B. We are going to start this video by dusting off the 4 feet on the bottom of the casting before I take it apart and do the rails. I would rather clamp on flat surfaces that I created in the first video rather than clamp on the way configuration that I'm about to machine. Now there is still a draft on the bottom of this and it's opposite from the draft on the top. I'm not quite sure why they did that, so I'm going to beat on these with a fly cutter and do this gently because you only have 172 screws holding this on there. So don't push this operation or you could be in for a hurt. So let's see if it rings and cuts off rather easily, which I hope it will. Lock everything down, no surprises. Take light cuts. Let's do it. Okay, the fun is about to begin, putting all of the way details on top of this particular casting. Now here's the issue. I cannot hold it down the way I held it down initially with it inverted because all of the tooling has to go down through the center, not only to undercut the inside of this feature, but the outside as well. 2 rails on each one of these protrusions. This particular surface in the front is not parallel to the machine surface in the back that I created, but you do have a lip. So clamping this down would be possible. Preferred? I don't know, we'll see. You could also, if you wanted to, dust these front pads off right here, use the back rail as your locator, and clamp against those. But flip side of that, there's nothing supporting it behind that, so you could very possibly dish this. That dish could transfer to the top and distort the final feature. Not a fan of that thought either. You could put a triangular block right here, banking against the surface in front of these 3 standoffs. It is very rigid, but then it translates to a single point of pressure distributing out across a partial here. I like that idea, but it's no time to gamble right now is what I'm saying. Clamping this down is a good idea. I like putting toe clamps out here, and here is the thought for this particular small segment. Toe clamps need to fight 2 forces. They need to fight rotational forces and they need to fight lifting forces. Anytime you can build a fixture that has a positive surface for your part to register against, you have effectively taken the rotational potential out of that fixture, at which time the toe clamps that you put on there only have to resist lifting. When you make a fixture and the possibility of that part moving, or you have multiple parts because then it becomes a locator feature as well, put that feature on your fixture. In between the clamps on the outside edge, you can have an eccentric puck that simply rotates into place, or put a 3rd clamp and just simply slide it in. Once you have this in, the screws that you will use become a whole lot more effective. And they can be smaller too because they don't have to apply enough downward force to resist torquing from the cut. So that's what I'm going to do. I'm not going to squeeze this part in a vise. I'm going to knock up a quickie little fixture, and I'm going to do exactly what I said. I will incorporate a stopper rail so that this thing will not spin. It's not a lot of force, but I don't want it to move. So if the possibility is not there, then it's just not going to happen. Should be quick, should be relatively primitive, but that's what I wanted to share with you. Stopper rail is really important. Even if it's a recess milled into the fixture, you want something positive to take that out. Okay? Keep that in mind. Let's build a fixture. Fixture is now complete. This was a bar end. The entire surface needed to be milled anyway, so instead of using pins to locate my part, I just cut a trough down the center. And banking against the finished surface, pushing it to the rear. These are the little bumpers that are going to keep it against the banking surface in the back. Remember that this front edge here is not machined and it is not parallel to the back side. It's out by about 7 thousandths and it's low in the center from the distortion of the casting. Now, one of the issues that you're going to find when you try to jig this up is we need to come in here with a key seat cutter and cut underneath this edge right here. So whatever you put up against there, you got to make sure that you have the room for the cutter to get in there and do its work, not only in the face, but up underneath. So keep that in mind. That being said, I went with a flathead screw for this. It's not going to twist because it's in a trough. It's not going to lift because I have 4 really stout little clamps on there. Life is good. I can access all the points I need to access now. I can still make the thickness, which is good. That's why I didn't make it full length, so I can still check here. I could also do it with a depth mic through the center because it's not resting on this top surface. It is in the channel, so don't forget that. All right, let's load up some tools. I already have the numbers as far as what needs to come off. Let's make this look like something we all recognize. First dimension on the second side is the thickness, 938. Fly cut it down. Coming up. Next step in the process is to bring in the width. Since these are bowed, it is really important to establish a clean surface on both sides and let that dictate the center line of the machine. At that point, you can go for symmetry. The bow will dictate where I stop making the cuts. I have no idea how much it's going to take to clean this up, but I know in the very center, I'm only 20 thousandths above the required spec, and out on the ends, it's considerably more. So the low spot in the bow is the target. I'm going to put a Sharpie mark on that, and I'm going to continue to cut until it goes away. Front surface is nice and clean. I'm about 6 thousandths into the low spot, actually about 3.5 into the low spot. I'm going to go around the back and do the exact same thing around the back, get my measurement, and I will split the difference and establish the center line. There's plenty of material on the thickness of these to approach it from this direction. I will come right back as soon as I cut the back and find my center line. The width is now established. Finished surface, front and rear. As far as the cutter telling you where the center of the part is, anybody that's really not following exactly what I just did, I took a cleanup cut on the front of this rail and I set my digital to 0. So just imagine the cutter is sitting right there, digital 0. When you make your final cut across the back, or any cut, let's say not a final cut, but a cut across the back, and it cleans up, you'll know that your cutter is now sitting back here. Well, if this is 0, and let's say this is 2 inches, you'll know that the center between those 2 red dots is 1 inch, and that's exactly what I just did. I took my cut, I saw how much had to come off, made my adjustment, and then it took equal amount from both sides of the center line. Right now I'm going to take the cutter and I'm going to pass the cutter down the middle of this part, establish the width of each one of these rails. All right, secondary machining note for anybody going, boy, I wish I had a digital readout. I just can't make cuts like that because I have backlash in my screws. Well, guess what? It's okay. This is for illustration purposes. I need to go, let's say roughly 62 either way on this groove. My digital readout, or your dial, is zeroed in the middle. I'm going to go beyond that. You can see the table moving towards me. I'm going to come back, and now my digital readout is sitting on 0. Now I can cheat, and I can go directly to the back side, or I can go directly to the front side. That's the joy of having a digital readout. If you do not have a digital readout, go beyond the number you're looking for and come back to it. Right now my dial is spinning clockwise. There is no backlash in this dial right now because I'm turning it clockwise and the table is moving that way. Okay? Make your pass, and to move to this side, which way do you turn the dial? Clockwise. And now you come back in this direction. Each one of these surfaces is cut with the dial moving clockwise. That way you can get a precision gap or a precision rail without worrying about backlash. Go beyond your number, come back to it, up and back. Great tip. I'm going to measure the thickness of both of these rails and the thickness of the gap in the center. We'll come back for the finish cut. Okay, using the technique that I just told you about, I am going to start on the opposite end of this part, go towards the rear of the machine, bring the cutter forward, finish the inside of the rear track, bring the cutter forward again, traverse the front rail on the inside edge, and finish not only the thickness of each rail, but the width as well. Let's do it. Front and rear of each rail are correctly positioned about center and true to dimension. For sake of cosmetics, I'm going to take a cut on either end the way I did on the bottom side of the bed and clean up the end faces. Actually called out as 6 inches long. And that just means I'd have to put material back on. Because that's not going to be 6 inches long. I could tell you that much. Maybe the back will. Not the front. They missed that one. Really nothing drives off of either one of these surfaces up front, left or right, so I will just clean them up. Do yourself a favor and do not deburr any of these edges at this time, because when you come back in with your 45-degree tool to do the rails, you're going to be looking for any type of witness mark that you have made contact. So if you deburr that, you're going to throw off the V that you're looking to create at a later date. Right now I'm fairly pleased with the way this is cleaned up. Very next step in this process is to split those front and rear rails right down the center. The finished dimension is 125, that's about 3 millimeters, but I'm going to go with an undersized cutter initially because I don't have a cutter that I can walk back and forth. I suppose I could use this one, it is undersized, but I want to go in with a full-size end mill and just finish as we go. So one side of this trough will be a climb cut, the other side will be a conventional cut. Not thrilled about that, but sometimes you just can't have everything. So let's split these things in half. Move on. This cut is 0.93 deep. That's a sound you don't want to hear. Oh, goodness. I hate 4-flute cutters on aluminum. Hate it. Ah. And that, my friend, is why you stay away from the finished dimension when you cut it. Do not throw away the remnant of the end mill if you can get the end mill out. Let's take a look at it. Inspect it thoroughly, make sure everything is there, because if it's not in your fingers, then it's in the part. And the next end mill you put in is going to do the exact same thing. Bummer. Didn't ruin the part, just ruined the cutter. Well, to quote a very dear friend of mine, sometimes you get the elevator, sometimes you get the shaft. And cracking off that 093 end mill was probably one of the luckiest things I ever did. Well, today anyway. This is a 109 2-flute cutter, which is far superior to the one I was just using. Now I can use the exact same technique that I used to do the center slot to do these and actually climb cut both sides of those for very accurate rails. I can do this relatively quickly. I will do this up and back a couple times and then come up with my numbers for the final setting. I'll show you what they are. But you can see what the trough is going to look like finished on the end. This is only about 5/1000ths in every direction off of what it should be. All right, let's do it. All right, machining note. This is a outstanding time to use the incremental and absolute positions on your digital. You can move to the center of each one of these slots in the absolute mode. When you get there, zero out your incremental side of your digital, and now you can go plus or minus an equal amount without having to worry about strange decimals based on the size of your cutter and the size of your feature. I need to be 437.5. That's 7/16 imperial off center each way. Now, based on the size of the cutter and the size of the slot, that 437 could just bounce all over the place and you'd have your hands full trying to keep track of what's what. If you zero your incremental side now, it's an equal shift forward and back. Do the same thing for the front slot. All right, the channels are successfully cut, and believe it or not, although they're being called out as a 3-place decimal slot, they are strictly relief and reference surfaces for the 45-degree features that will locate the carriage and the tailstock. So basically, they're there, they look good, they should be symmetrical if you did it right, but if you messed something up, don't worry about it because it's the 45-degree surfaces that do all the work. Now, sequence of operations. I am just dying to put them 45-degree chamfers on the top and try the other pieces out. But, and there's always a but, right? But is this dimension right here, this 188. If you put the chamfers on first, you may have a real problem measuring that 188. So while there's still a square corner right there, I'm going to put the key slot cutter in. This guy here. I'm going to go up and back, front and rear, and then I'm going to pass it through the center. Now you'll notice on the center there is nothing defining how wide this is. Wait a minute, there it is, 750. Now the 750 is driven exclusively by this little guy right here. This is the plate that holds the tailstock pinched to the ways. So however wide this is, however symmetrical this is, that should dictate this 750. That 750 is not critical, but it is clearance for this guy right here. So as far as 3-place decimal is concerned, it should just say make sure this fits in there. So I'll do that all at the same time. Hopefully the face of this cutter here is wide enough to hit the surfaces where the rack mounts in the front, and there's a clamp that goes on the carriage in the back that also needs to register that. So be very aware if you're using a T-slot cutter or a Woodruff cutter, key seat cutter to do that, that you clean up the entire face. And it's very deceiving because of the way this thing is dimensioned. That dimension line goes outside the casting and looks like an elevated feature, where that is actually an elevated feature, and that's a dimension line. So watch out for that. All right, let's set it up. Do it. Moving on to all the undercut features. Very much like the way I set some of the tools on my CNC, I use a pin. Roll the pin back and forth until you feel a gentle bump, nudge, or whatever. Do not come down on the pin. If anything, bring the tool up until the pin clears, and then slowly bring the tool back down until you feel a pinch or an interference. Knowing the diameter of the pin and the thickness of the cutter, you can now make an offset bring the top of the cutter flush with the location plane. 375, 125. If I drop this 500, the top of this cutter will be even with the top of the part. I can then go the dimension on the print for the feature. Knowing the diameter of the cutter, subtract the diameter cutter from the width of whatever feature you want to create. Go halfway in each direction. I will do the exact same thing I've been doing all along. I will go beyond the feature boundary and come back. Climb cut one side, climb cut the other side. The cutter will start in the back on this corner and end up in the front on this corner. 2 cuts. All right, let's throw a rag over that and blow it off. These are like 4 little bathtubs in there. You put an air gun to that right now and you're going to be wearing these chips. I will not remove the cutter or change any of the heights because it still needs to be cut under the front and rear. But I would like to clean it out, make sure it's cutting well. So let's take a look. Let's get this shower on film. Camera has been repositioned. I am on the right hand side of the machine behind the table at this point, so you're looking at the rear of the casting. And the wind is picking up, so my vents are jumping around a little bit. Sorry about the noise. I will take climb cut up the back, bring the cutter to the front, reposition the camera for the front just so you can see it, and make that pass as well. Let's do it. You can see the small elevation on the part as a result of the inner and outer cuts. Simply just take the cutter and traverse front to rear and knock those off. I'm going to try not to hit the actual casting, but I would like to remove that bump. I think it's kind of uncalled for. Let's do it. Oops. While I have the opportunity, I'm going to take a small cutter and knock the ugly off the inside here. I'm going to slap the ugly right off of that right there in the center. I'm only going to be able to get like I did on the bottom. I'll still have to do the points by hand, and I will do the end by hand as well. That's all kinds of nasty in there, and I'm going to smooth that out so that I like it. But we're going to just knock the high spots off, make it a whole lot easier to file. Bear with. Here we go. All right, let's get an interim quick look at this before the rails actually get cut at the 45. I could get in there and blend whatever I could blend from this angle, but I'm going to do the shoe shine on those. I'm going to put a piece of emery up and over top of it, a long thin strip, and I'm just going to pull it back and forth like shining shoes, and that should give me a nice blend top and bottom. And you can see the ends are nice and cut. Front is as well. Let's see if you can see the back. That face surface in the back is 155 tall. Same in the front. The rail that connects to that, the rack that connects to that is 125. I wanted to make sure I had sufficient room for it. Next step, we'll put the 45 in and pray that it all works out well. So far, so good. I like what I'm seeing. Let's put that 45 tool in and finish up. Before I actually cut the 45-degree features on all 4 of these sections right here, I would like to point out that although precision at this level is a really nice thing to have for visual symmetry, basically none of these surfaces are working surfaces. The surfaces under here are good for the rack, but none of these rails up here right now will determine the movement of the tailstock or the carriage. It's all about the chamfers. So if you slip on a couple of dimensions here and don't hit these right on the money, like this one, it's okay. It really is okay. What you really need to pay attention to is this next operation where these 45-degree chamfers go on. They must all be at the same height and correctly positioned, or you will have problems. Now, since the 45 degrees will come to about a 15 thousandths land on top, you can see how the width doesn't matter. It's all about the origin point where the planes intersect. Right here. This point right here on both of these is what's critical. These angles must originate from that particular point on all of them. And it's not necessarily from here to here. It is from here to here because that's the tailstock, and from here to here because that's the carriage. So come up with the numbers that you need to come up with to create the 55 by 45 as defined right there. And everything else here is just kind of reference. Look for your center to center. It's 625 center to center for the inside, and 1 inch 125 center to center for the outside. All the angles will originate from those 2 points. Okay, let's take a deep breath and cut it. Finishing the 45s is going to be an 8-pass 2 times. I'm going to rough it out first, stay 5 thousandths above, and I'm going to come back to the original start point right where the cutter is now, make my final adjustments, and finish this off. Patience is everything right now for these 45s. Patience. Here we go. Actual cut time, 28 minutes. little closer look. Nice even cut. Super finish. I love the finish. Brand new cutters for this. Literally just picked them up an hour ago. Did not want to take the chance with an old cutter. If you do have a comparator, now would be the perfect time to find out exactly where the theoretical tip of your tool is. Historically, I know these tools are a couple thousand shy, so I stayed a couple thousand shy of the depth required. And no, for all you guys that are going to say, why didn't you do the both inside cuts at the same time? You can't. The distance across the flats, or the distance across the theoretical formed flats, is farther than the depth. So the tip of the tool would have been digging into the relief in order to do both of the inner surfaces at the same time. It really does need to be done up and back like you just saw. All right, let me clean it up, get ready for the drilling operation. Move on. I'm actually kind of glad that's behind me. I was holding my breath on that one. All the features that can be done in this orientation are complete. There are 4 mounting holes on the very end down this side here for the headstock. That's the headstock side. And you can tell the headstock side from the tailstock side by these bosses right here that support the lead screw, or the drive screw, drive shaft. When you're done, if all went well, these spaces on the top are 15 thousandths, about 1/3 of a millimeter flat. I'm going to take this out, clean it up. The only polishing I'm going to do to the top, I'm going to put a little bit of blue magic polish on a emery, or excuse me, on a paper towel, and rub them down to make them look like they're ground. I think that's probably the safest way to go right now. A couple of tapped holes in the front, a couple more tapped holes on these pads here for supports, and one in the end for a gear cluster. Simple operations, I'm not going to show those. This 45-degree detail here was probably the focus of this particular video. Now, one other thing I wanted to share with you when you have a situation like this. One thing I do not like about flathead screws is the drive hex in a flathead is usually too small for the size of the screw and the amount of grip you want out of it. Let's say you torque this down to the point where, okay, it's about to strip out or snap the wrench off. If you want to amplify the amount of torque that you have on that, use the jack screw in the rear. Tighten this one down, and it's going to cantilever about the clamp screw, and it's going to drive down just as much. Or it's going to increase the torque, let's put it that way. Now let's put a wrench on there, and I can bend this pretty far without that coming out. Let's just say I don't want to strip the screw out. I'm going to unloosen the heel screws on this, and now this is finger tight. Keep that in mind. If you got one that's being a booger, doesn't want to come out, unloosen the heel, and away you go. Let's pop this thing out, clean it up, take a look out on the bench. Let's get a closing look at the work so far. Looks ground, doesn't it? I like it. You can see a little bit of tool noise in there. If you get really on the right angle, you can see it. A little higher RPM might have been a good idea for that. The headstock mounting holes are in. Ribs were all blended out. I will consider that a win. I am very pleased with that. That came out nice. Fixture was well worth the time spent. And I am going to keep you hanging until the very last minute to see anything going on this. I'm going to try it. Of course, I'm going to try it, but I'm not going to show you until it's almost done. I am thrilled. Thank you very much for hanging in there. This was an awful lot of work to do what looks like a relatively simple feature. And I do appreciate it. Hope you're well wherever you are. Joe Pye at Advanced Innovations in Austin, Texas. I'm out.